Ever wondered how the flick of a switch lights up a room? Let's unravel the mystery of electric power. You see, electric power is essentially the rate at which electrical energy is transferred within a circuit. It's like a highway for electrons, allowing them to move and carry energy from one point to another. This transfer of energy is what powers our devices, lights up our homes, and runs our factories. Now, to measure this rate of energy transfer, we use a unit called watt, named after the Scottish engineer James Watt. So, when we say a light bulb is 60 watts, we're saying it consumes electrical energy at a rate of 60 joules per second. Think of it as the speed at which our electrical energy is being used. In everyday language, when we talk about electric power, we're usually referring to the production and delivery of this electrical energy. It's about how we generate this energy, how we transport it, and how we use it. This energy is usually produced by electric generators, such as those found in power plants. But it can also come from other sources, like electric batteries. And once this energy is produced, it's delivered to our homes and businesses through an intricate network known as the electrical grid. So, to sum it up, electric power is all about the transfer of electrical energy. It's measured in watts, which tell us the rate at which this energy is being used. And when we talk about electric power in a broader sense, we're talking about how this energy is produced, delivered, and used in our everyday lives. Now that we know what electric power is, let's dive into how it works. Scene script. Ever heard of the term wattage? Let's break down what it means. Just like mechanical power, electric power is the rate at which work is done. It's measured in watts and is represented by the letter P. You might hear the term wattage thrown around in casual conversation, but what it really means is electric power in watts. But how do we get this power? How does it come into existence? The answer lies in an electric current. Picture this: a steady stream of electric charge flowing like a river. This charge, let's call it Q, moves through an electric potential difference, also known as voltage, and represented by the letter V. This movement, this flow, is what generates electric power. This electric current, represented by the letter I, consists of a charge of Q coulombs passing through a voltage difference of V. The power, or the wattage, is thus a product of the current and the voltage. In simpler terms, power is the result of volts times amps. Now let's dig a little deeper into these terms. A volt is a unit of electric potential difference. Think of it as the force that pushes the charge through the circuit. An ampere, on the other hand, is a unit of electric current. It represents the rate at which charge is flowing. So when you multiply the force that's pushing the charge, volts, by the rate at which the charge is flowing, amps, you get power in watts. That's the work being done per unit of time. This is the fundamental principle that underpins the functioning of all our electrical devices, from the smallest cell phone to the largest power grid. It's the heartbeat of our electrical world, the rhythm that keeps everything running smoothly. So when you hear watts, think volts times amps. It's that simple. Electric power doesn't just light up our homes, it transforms into other forms of energy. Let's see how. The fascinating world of electric power revolves around the movement of electric charges through an electric potential difference, commonly known as voltage. This movement occurs within various electrical components that are part of electric circuits. Now, these electrical components can be broadly classified into two categories: active devices or power sources, and passive devices or loads. Active devices are the heart of the electrical circuit. They're the ones that convert some other type of energy, such as mechanical or chemical energy, into electric potential energy. This happens when an electric current is compelled to flow from a region of lower electric potential to one of higher potential. In other words, positive charges move from the negative to the positive terminal, and work is done on these charges. Active devices include electric generators and batteries. Interestingly, some devices can function as both a source and a load, depending on the voltage and current through them. A prime example of this is a rechargeable battery. It acts as a source when it provides power to a circuit, but it becomes a load when it's being recharged. On the flip side, we have passive devices or loads. These are the pieces of equipment in the circuit that consume the electric power produced by the active devices. They use this power to perform useful work, like lighting up a bulb or spinning a fan. The energy transformation here is from electric potential energy to other forms such as light, heat, or mechanical energy. In essence, the transformation of electric power is a dynamic process involving the interplay of active and passive devices in a circuit. The active devices generate power by converting other forms of energy into electricity, and the passive devices utilize this power, transforming it into the forms of energy we use in our daily lives. It's fascinating how electric power can change forms, isn't it? Now let's see how we produce this versatile power. How do we produce this electric power that lights up our world? Let's find out. Electric power, the lifeblood of our modern world, doesn't just magically appear. It's produced in a variety of ways and then delivered to our homes and businesses. This process is a marvel of engineering and infrastructure, and it all starts with a source of power. One of the most common ways we generate electric power is through electric generators. These machines convert mechanical energy into electrical energy. The principle behind it is quite simple. A magnet is moved near a wire to create a steady flow of electrons. The energy that moves the magnet can come from a wide range of sources, from the burning of fossil fuels like coal and natural gas, to renewable sources like wind and water. In addition to generators, we also have other sources of electric power, such as batteries. Batteries store chemical energy and convert it into electrical energy. This is why batteries are so essential in our everyday lives, powering everything from our mobile phones to our cars. Once the power is generated, it needs to get to the end users. That's you and me. This is where the electric power industry and the electrical grid come in. The electrical grid is a complex network of power plants, transformers, and power lines that transport electricity from where it's produced to where it's needed. The electric power industry is responsible for maintaining this grid and ensuring that power is always available when you flip a switch. This isn't always an easy task, as the industry has to balance the supply of electricity with the demand and also deal with any power outages that may occur. It's truly fascinating to think about the journey electricity takes from the power plant to our homes. Every time we turn on a light, we are the end point of a process that starts with the generation of power and ends with its delivery through an intricate network of power lines and transformers. Electric power doesn't just magically appear, it's carefully produced and delivered to our homes and businesses. We use electric power in so many ways, often without realizing it. Let's explore. Consider the simplest of daily tasks, flicking on a light switch. That light bulb glowing overhead, it's a direct result of electric power being converted into light energy. But it's not just about lighting up our living spaces. The same principle applies when we use electric stoves to cook our meals, where electric power is transformed into heat energy. It's fascinating, isn't it? The journey of electric power doesn't stop at our homes. It extends far beyond, reaching out to power the wheels of industry. Electric power is used in manufacturing processes, from running heavy machinery to powering automated assembly lines. It helps in producing everything, from the clothes we wear, the cars we drive, to the smartphones we can't seem to live without. But how does this power reach all these places? Through a vast network of transmission lines. Electric power can be delivered over long distances with minimal energy loss, thanks to the marvels of modern technology. It's a massive, intricately woven web, connecting power plants to homes, schools, hospitals, factories, you name it. And it's not just about powering gadgets or industrial machinery. Electric power has broader applications too. It's used in public transportation systems, making our commutes easier. It powers our telecommunications, connecting us with the world in real time. In the medical field, electric power is indispensable. It powers life-saving equipment in hospitals, like ventilators and heart monitors. It enables advanced diagnostic tools like X-rays and MRIs, helping doctors see inside our bodies to diagnose and treat illnesses. The uses are virtually endless, from the mundane, like charging our phones or powering our refrigerators, to the extraordinary, like propelling rockets into space. Electric power is everywhere, woven into the very fabric of our lives. So, the next time you switch on a light, remember the journey that electric power has made to reach you. It's a journey that starts at a power plant, travels through miles of transmission lines, and ends at the flick of your switch. From lighting up our homes to powering industries, electric power truly is the lifeblood of our modern world.